What's up, guys? Welcome to the video, probably the only video you're going to have for Unit 2. This is going to be your introduction to logic and the logic project, which will be all we're going to do for Unit 2. Unit 2 is going to be the logic project, and it will also be your first quarter project. So after this lesson, we'll be moving right into Unit 3. Here on this first page, we have a couple of advertisements, because this is something that you guys are going to need to find for your project. So we got a Coke ad, cell phone ad, pop chips, Wheaties, flu shot. You guys are going to have to find an ad for your project and write a conditional statement from that ad. Of course, you guys don't know what that is yet, but I'm going to talk a little bit about that in a second. So the first thing you need to do for your project is find an ad and write a conditional statement, and that'll have a separate due date than the project. So key concepts. Conditional statement. A conditional statement is just an if-then statement. It's made up of a hypothesis and a conclusion. So if we look at our symbols, the P is the hypothesis and the Q is the conclusion. Now if we're talking about an if-then statement, the hypothesis is the part that comes after if, and the conclusion is the part that comes after after then. Okay, and it's going to read if P, then Q, or P implies that Q happens. Okay? I know that might be a little confusing now that we don't have a concrete example, but we're going to move into that in 1 second. I just wanted to get down kind of the basics of logic. So you will have to do a conditional statement for your project. So based on your advertisement, it's going to be if something happens about your ad, then something else will happen about your ad. So your conditional statement is going to be your original statement. Then there are going to be 3 other kinds of statements: converse, inverse, and contrapositive. Okay. So if we look at our first example, we have if the measure of angle A equals 115, then angle A is a Q. So that's the conditional. If P, then Q. This is the way you write it in symbols, and this is the way you would read it. Now, the first other kind of statement we're going to talk about is the converse. So in the converse, you exchange the hypothesis and the conclusion. Okay? So that means the hypothesis and the conclusion are going to switch. So if we look at this example, it's if the angle is acute, then the measure of angle A is 15, which is the opposite of what we said before. So if Q, then P. So we just switched P and Q. The next type of statement is inverse, where you negate both the hypothesis and the conclusion of the conditional. So negate just means you turn it into a not statement. Okay, kind of the opposite. So if we look at the example, we have if the measure of angle A does not, because this equal sign means does not equal 15, then angle A is not acute. So you can see how we negated that by adding the word not. The way you're going to write that is you put a little squiggly in front of it. Not, if not P, then not Q. And then finally, we have the contrapositives, and you're going to switch them. So you're going to switch P and Q, and you're going to negate them both. So again, negate means not. So if we look at our example, if angle A is not acute, then the measure of angle A is not 15. So as you can see, we got Q in front now, so not Q, then not P. Okay, so I just want to write them again real quick so you kind of get the idea. So first we had P, then Q. Then we switched them, Q, then P. So that's the converse. Now the inverse is the not version of the conditional. So we had not P, P's in front again, not Q. And then for the contrapositive, you switch them, and you make them not. So we have not Q, not P. All right, I know this seems a little abstract now, but we're about to do a concrete example, a more concrete example. So, given the following condition statement, state the hypothesis and conclusion. It's inverse, converse, and contrapositive. Okay, so our conditional statement is if two angles are vertical, then they share a vertex. So, like it said in the notes before, the hypothesis comes after if, but before the comma. So the hypothesis is two angles are vertical. And then the conclusion comes after the word then. So the conclusion after then is they share a vertex. Okay. So our conditional is if two angles are vertical, then they share a vertex. Now we want to write the inverse of that. So if you look at your notes from up above, you can kind of see how we're going to structure it. So inverse is not P, not Q. So we have if two angles are not vertical, so we added the not to negate it. Then they do not share a vertex. Okay, so that's going to be the inverse. We just negated the conditionals. The conditional, the hypothesis, and the conclusion. All right, now for the converse, if you look at your notes above, we're going to switch P and Q. We're going to flip them around. So Q is going to come first. So now we're going to have if two angles share a vertex, then they are vertical. So here we just flipped P and Q around. And lastly, we have the contrapositive. We're going to switch Q and P, and then we're going to negate Q and P. So we're going to add a not in front of it. So if two angles do not share a vertex, then they are not vertical. So that's the conditional, inverse, converse, and contrapositive of a more concrete statement. So I hope this gives you guys a better picture of kind of what we're doing, what you're going to be doing for the logic project. Now I ask what statements are equivalent. So which statements, if one is true, the other is true, they're both equal. Well, if we look at the conditional, if two angles are vertical, then they share a vertex. Which one is that the same as? So if the hypothesis, if the conditional is true, then the contrapositive is also true. So those are the two equivalents. Conditional equals contrapositive. So if we look at this example, conditional, if two angles are vertical, then they share a vertex. The contrapositive is if two angles do not share a vertex, then they are not vertical. So the conditional is true, that means the contrapositive is its logical equivalent. Also, if the inverse is true, the converse is true. So inverse and converse are logical equivalents. So if we look at our example, we have if two angles are not vertical, then they do not share a vertex. The logical equivalent of that is the converse. If two angles share a vertex, then they are vertical. So just try to remember that conditional and contrapositive are equivalent, and then inverse and converse are equivalent. Next, we have two laws, or actually, nope. Now we're going to do notation. So we're going to go over how to notate each. So for symbolic notation, we have the same conditional statement. If two angles are vertical, then they share a vertex. So we're going to translate it into symbolic notation. So we're going to translate each of the following symbolic notations. The hypothesis is going to be P, and the conclusion is going to be Q. Then you have a series of statements. The arrow means if then. A two-way arrow means if and only if. The little squiggly line means not. The pointing up arrow means and. You can think of it like that looks like an A, and. The downwards pointing arrow means or, and then the three dots mean therefore. Okay. So if we take our original conditional statement, if two angles are vertical, then they share a vertex. And we look at the symbolic notation, we can translate it. So here we have P upward arrow, not Q. So that's going to be two angles are vertical, which is our P. And, because the upwards arrow means and not, because you have the little squiggly before the Q. So, and not, and they do not share a vertex. Okay, next we have Q, arrow P. So we're going to start with Q this time. If, so with the arrows, you always start with if for the arrow pointing one way. If two angles share a vertex, then they are vertical. Okay, now we have P and then one-way arrow Q. So it's kind of going to be the same as the last one, except Q and P are flipped. So if two angles are vertical, then they share a vertex. And lastly, symbolic, we have Q, and then we have a two-way arrow in P. So the two-way arrow means if and only if. So first we're going to start with Q, because the if and only if goes in the middle. So two angles share a vertex. That's our Q, comma, if and only if, because we have the two-way arrow, if and only if. Two angles they are vertical. So if and only if they are vertical. So that's how you write that out. Now we're going to practice taking statements and writing them in symbolic notation. So we have two angles are not vertical or they share a vertex. So two angles are not vertical or they share a vertex. So we have our not, which lets you know it's going to be a negated, so it's going to be a squiggly line, like up here. Two angles are not vertical. Two angles are vertical was our P. So it's going to be not P. Then we have or, so we need the down pointing arrow. And then they share a vertex was our Q. So this was our conclusion, our Q, and this was our hypothesis. In the next one, you can see that they switched the hypothesis and the conclusion. So two angles share a vertex comes first. So that would be Q first, conclusion first. Therefore, so we notate therefore by using the three dots. So we can add those in. Therefore, they are vertical, which was our P. So that is how you go from symbolic notation to writing out the statements. Next, we're going to talk about disproving statements. So all you have to do to disprove a statement is to present a counterexample or give a counterexample. So a counterexample shows that a conjecture statement is false. So if we look at the first one, we have if the product of two numbers is odd, so one number times another number, so A times B is an odd number, then the two numbers must be even. So A and B must be even. So now to disprove that, all we have to do is find one counterexample that fits. And to disprove something, all you need is one counterexample. So A times B equals odd, and A and B are even. So let me see. Well, 1, so let's start with an odd number. That's an answer. So 3 is odd. Okay. And then two numbers that multiply together to get 3 that are not even are 1 times 3. So this is a counterexample because 1 and 3 are both odd numbers, but when you multiply them together, they also give you an odd number. So this disproves the conjecture. Okay? Look at the second one. We have, you can connect any 3 points to form a triangle. So I'm going to draw 3 points and see if it makes a triangle. Actually, we know an easy one. If you draw 3 points in a straight line and connect them, that doesn't make a triangle. So 3 points in a straight line. So that's kind of how you disprove, give counterexamples for conjectures. Now we have 2 laws that you guys are going to need to use. First, the law of detachment says if the hypothesis of a conditional statement is true, then the conclusion is true. So that's just if P then Q is true and P is true, then you can say that Q is also true. So if we look at an example, if a student gets an A on the final exam, then they will pass the course. So our hypothesis is a student gets an A on the final exam. That's our P. Then the student will pass the course. That's our Q. So all the law of detachment says is that the statement is true, and then P is true. So P is true. So Felicia got an A on her final exam is true. From that, you can conclude that she will pass her history course. So P is true. She got an A on her history final exam. If that's true, then she will pass the course. So that's the law of detachment. However, it does not work if you try to say that Q is true. So we have a conditional statement. If 2 angles are adjacent, RP, then they share a common vertex, is RQ. Okay. It says angles 1 and 2 share a common vertex, which is Q. So you cannot use the law of detachment for this one because Q is true does not mean P is true. So this is an example where you can't use the law of detachment. So that's the law of attachment. That one's pretty straightforward. Next is the law of syllogism, which says if P then Q is true and Q then R is true, then if P then R is true. So if it is July, then you are on summer vacation. If you are on summer vacation, then you work at a smoothie shop. You can conclude that if it is July, then you work at a smoothie shop. So we have our hypothesis, it is July, and then we have a conclusion. You are on summer vacation. Then the next conditional statement starts with that same conclusion from the previous one. So that becomes the hypothesis of the next statement. If you are on summer vacation, then you work at a smoothie shop. So you have another conclusion. Then they're joined by the blue. They're joined by you are on summer vacation. So you could say, if it is July, then you work at a smoothie shop. Okay, if we look at this other example, if figure A is a square, so we have our first hypothesis, figure A is a square, or a figure is a square, excuse me. Then the figure is a rectangle, and then the next conditional statement uses the old conclusion for the new hypothesis. If a figure is a rectangle, then the figure has four sides. So from that you can conclude if a figure is a square, if red is true, then the figure has four sides is true. So green is true, or purple. Because it's linked by that conclusion. They both share the blue part. Okay. Now I'm going to do two examples, two more concrete examples, just to make sure you guys got it. So use the law of detachment and the law of syllogism to make any possible conclusion, right? Not possible if you cannot make any conclusion. So our conditional statement is, if you want to get a driver's license, you must take a driver's education course. So you want to get a driver's license is your P. Then you must take a driver education course is our Q. John wants to get a driver's license, so that's the same as our P. So P is true. So that means that Q must be true. So that means that if John wants to get a license, then John must take a driver's education course. Now this is the law of detachment because the hypothesis is true, which means the conclusion must be true. So this is detachment. Law of detachment. For number 2, we have if you miss more than 5 days on of a mathematics class, then you will not get a good grade. Then you see if you do not get a good grade again, which means it has the new hypothesis is the same as the conclusion from the first conditional statement, then you will not be on the honor roll. So again, you see two blues. You see the two blues are connected. Connect the two statements, so you know that that's the law of syllogism. Okay. So you could conclude that if you miss more than 5 days of math class, then you will not be on the honor roll. So again, the two statements are connected. In the first statement, it's the conclusion, and the second statement is the hypothesis. They have that in common, so you can use the law of syllogism here. So that's all I have for you now. I want you to finish the rest of the statements, and then show it to me when you're finished, and then I will give you the introduction to your project. All right. See you next time.